Pros and cons of solar, wind, hydro, nuclear, and other energies. Part 2. This is Cleveland Jones. Let me show him here. Professor Cleveland Jones. This is Paul Taylor, consultant. And this is me. A week ago, we discussed the pros and cons of coal, oil, and natural gas. And today is the day of solar, wind, hydro, nuclear, and as Professor Cleveland likes other energy sources. So let's start with solar. Paul presenting his thoughts about solar pros and cons, and Cleveland will be following him. So please, Paul, is with you.
Well, hi, everybody. I'll just briefly go through the pros and cons of solar energy. Solar is a renewable energy, and it's going to be renewable and sustainable well past the extinction date of humans on this planet. The great thing about solar panels, because this is what we're talking about, are solar panels, is that they can be placed anywhere, and you've seen them. You've seen them on the roofs of houses. You've seen solar panels laid out in fields, i.e. a solar panel farm. And all they're doing is sitting there collecting energy and transmitting that energy then into or to the consumers, or whether they be household consumers or industrial consumers. So it's a very cheap form of energy generation. Yes, there are some downsides, because we could say that solar panel has a very low effect on the environment. But you must remember that the generation of those panels requires the mining and refining of some very sensitive raw materials, which will have an effect on the climate and the environment. And ultimately, solar panels are recyclable, but at present, our systems they lack the infrastructure to collect and facilitate this recycling process. So as I said, solar panels can be placed anywhere. And although the startup costs are significant, the running costs are minimal. And a household, for example, they can recoup the costs from the installation in about 6 to 10 years. And then they start reaping the benefits. Friends of mine, for example, they have solar panels, they have installed inverters, they've got batteries stored away somewhere in their homes, and they're selling electricity back to the supplier. So they are making, they're not spending money, but they're actually making money from using solar panels. So in the long term, you can save quite a bit of money using solar panels, and they have low maintenance. As long as you keep those solar panels clean from dust, etc., there's very little maintenance associated with solar panels. So what are the cons? The cons are obviously the cost of installing solar panels, even to a household. You're looking at around $18,000, which is quite a lot of money. And then we have to look at the dependency of the solar panels on receiving sunlight. So in many parts of the world, solar panels simply are not going to work. Even in the tropics, most days in the tropics are cloudy because of the humidity. So you have to be very careful where you place these solar panels and they take up a lot of space wherever you place them. The solar panel farms are we've got quite large, quite a few acres to accommodate these solar panels. And then when you've got the power, how do you store it? Because you can't deliver it all in one go when you have a sunny day. So, well, we have batteries, and batteries are quite costly. A simple single lead acid battery for a house will cost anywhere between $200 and $800. But if you want to move to a residential lithium ion solar system, this is going to cost between $7,000 and $14,000. I've mentioned that the environmental downsides to solar panels is the mining of sensitive materials which go into the manufacturing of these solar panels, and they do create a considerable amount of greenhouse gas. The Office of Energy Efficiency and Renewable Energy have issued a report that reveals that solar panels pay for themselves in terms of greenhouse gas emissions within 1 to 4 years. So this mitigates their use. But these panels, they are made up of some environmentally harmful substances, and proper disposal is critical. And at present, the recycling options for solar panels remain limited. And this is simply because of their lives. They have a life of around 25 to 30 years. So people are not thinking about recycling solar panels to date. Okay, I'm finished with. Would you like to comment, Cleveland?
Yeah.
You want to
Paul and Cavani, I tend to agree on most of the points that Paul brought up. Sure, it's renewable, far into the future. I tend to focus a little bit on the cost structure because OPEX as opposed to CapEx, certainly very low operating expenses. I'd say that the CapEx is medium in relation to some other sources, certainly higher than for, on the large scale for a coal generating plant, but certainly a lot less than many other alternatives and more than others. So I would say it's medium, but it does have the aspect of potentially being a distributed energy source where you can place it where the demand is, especially if you're not talking about giant solar farms. So that is a potential advantage in many cases. And certainly the fact that you can implement, a solar farm even on very fast track. This is particularly important for areas and countries or regions that decide they need to cover energy demand or imbalances really quickly. So yes, the pros are there and pretty clear. I think the cons are a lot more complex because certainly the CapEx requirements may impede a lot of less developed countries, for example, even though many of them are in prime areas for solar radiation to implement solar energy. The location and climate requirements, which Paul mentioned, weather dependence, intermittency, certainly the large land footprint of solar farms. People tend to not consider this, but if you have a large solar farm, there's not too much else that you can put in between. You certainly can't plant trees because they'll provide shade. You can't do too much else, so it's a lost area. Maybe in some cases you can put something in between the rows, especially if it grows low, but that's not an ideal use of the land. The materials constraints that Paul alluded to, certainly with some of the difficult to mine and obtain materials, the environmental impact of the inputs and of the production, even though that's mostly in China, but it's still a worldwide pollution generator. And even though Paul said maybe low maintenance, but there's many places where the self-cleaning equipment had to be installed. along with the panels in order for them to keep working close to maximum design, and that ends up being a significant part of the capital expenditure to make those solar farms work. Certainly the limited lifetime. When we talk about, things that can last 50 years or 100, sometimes like a hydroelectric plant, well, certainly solar panels have a limited lifetime. The amortization of the cost has to be considered, the decommissioning and recycling, that's not a priority right now. And of course, the geopolitical implications of relying on production from China, which at this point dominates world production at extremely lower cost than anywhere else, whether in Europe or the United States or anywhere else. So there is some concern that at some point, you're giving up the opportunity to provide industrial opportunities for each country to develop their own solar industries. But hey, solar panels are so bottom dirt cheap that, at this point, countries are just taking advantage of it. So it's a complex situation. And one last point I wanted to make is that we're talking about solar panels. CSP, concentrated solar power from reflectors onto collectors on towers and then molten salt generating electricity. It's another source. It may be less subject to variations in intermittency because, of course, the molten salt is a big mass, retains heat for over 24 hours, so you don't have any more this night and day thing. But, of course, over several days, you could still have some variation. But it's just so that we can consider CSP as part of the solar as well, which has its own complications and in some places maybe is appropriate.
Yeah. One of the things that we haven't mentioned is the efficiency of converting the solar energy into electricity, and that must be improving with each generation of panel being marketed.
Yes, we're talking about getting closer to the theoretical maximum, but just like in porosity in the oil and gas industry, there's many instances where in practice you're way beyond the theoretical maximum. How can that be? How can you be beyond the theoretical maximum? Well, in oil and gas reservoirs, that is possible. And in solar power with some panels, that is possible because you have layers that absorb different radiation, parts of the radiation spectrum. So we're making big strides. It used to be we used to talk about 20%. Now we're into the high 20s and into the 30s and getting up there.
I didn't see, if you mentioned, I lost it, the backup system that we use natural gas for. Sometimes we need that. And another point, the destination of used materials. I mean, debris and these 2 points. Could you please both talk a little bit about this?
Well, solar panels simply can't be used as a replacement for the base load because we're relying on solar sunlight. So when you don't have it, we have an intermittency that can't be accommodated. So solar panel, like wind energy, has to be used in tandem with something else if we're going to replace the base load.
Exactly. That is important. But I have to say that, what overrides all concerns usually is cost. When the cost is so low, then people go for the solar anyway. There's a
follow the money.
There's a very interesting piece of information. I think it's in Howard. They're making fences with solar panels, and they say, well, we save the cost of the fence, plus we get some energy because even though they don't point the right way or anything, the efficiency is lousy, but it's still okay because the cost is so darn cheap from Chinese panels. Who cares? So, at a certain point, you say costs can be so low that it doesn't matter if you have to have this or if you have to have backups or whatever.
Looking at the cost driven, you are right. But the destination of used materials, what do you see this? In 10 years, we will have an amount of material that reject. How
Eventually,
can we deal with that?
Decommissioning is going to be a big problem. As Paul said, recycling sounds great in theory, but in practice, we're
Yeah.
still in the infancy of the industry, so we don't
That's right.
really have that going. But it's going to be a big challenge. And in fact, those panels are so complex, they're a mixture of so many materials and in different combinations, that it's going to be a nightmare. For sure.
That's
That is a problem that we're going to have to build in,
A
just
big
like
problem for the
decommissioning
future.
oil and
Yeah.
gas facilities.
Yeah, that's right.
Yeah.
Let's go to wind.
Yes,
Paul.
Wind. We all know, we've all experienced windy days, and we've all seen those wind generators up on the hillsides or in people's, well, not in people's backyards, but certainly in farms and other places. Wind is free, it's clean, it's constantly a renewable energy source. But it's very difficult to find some of the pros for wind energy, other than what I've said. I did through my research, I found something about space efficiency. Yes, each individual windmill they have a very small footprint, each wind turbine does. But to generate significant amounts of electricity, you need wind farms. Yeah, you can farm in between, or you can do things in between each wind generator, but I find it very, very difficult to think of that as a real pro. Yes, it's cheap energy, and the current estimate is that it costs about 2 cents per kilowatt hour to generate. But yeah, it's very, when you look at the cons, these wind farms, they're an ugly blot on the landscape, especially a picturesque landscape. Where I live, we have rolling green hillsides, and they're covered in wind generators, and they're simply ugly. Very hard to blot them out and think that they're not there. But the biggest disadvantage these generators have is the consistent supply of wind. But it's not just the supply of wind, it's the wind power itself, because the electricity, the potential to generate electricity is directly proportional to the wind speed. So wind is like solar, it's not a well-suited use to replace the baseload energy source. However, like solar, we are improving the energy storage technology, and as that continues to become more efficient and more cost effective, it could be possible for wind energy to become a more reliable source. But until that happens, we're going to have to tandem them with other energy sources to make sure the base load is uninterrupted. But the environmental impact, well, you don't think of wind having an environmental impact. It doesn't. But those wind generators, they need manufacturing, they need transportation and installation, and they all have an impact on the environment. And then we have the noise that comes from them. Oh, sorry, just to step back to the environmental impact. They have an impact on wildlife, birds, bats. They don't know when these massive arms are swinging around, and there's a zero chance of surviving a collision with one of those arms for the birds and the bats. But so we have noise pollution. Yeah, we've all heard the noise coming from those generators. But also the biggest impact, one of the bigger impacts, is the location. You can't have wind farms in cities. So they are almost ubiquitously located in rural areas or offshore. And that creates a distance then between the generation and the consumers. And you need to be able to build an infrastructure to take the electricity being generated and supply it then to the consumers. You need power lines. Again, if you're onshore, you're going to be cutting down trees or making pathways for the power lines, and that also has an impact on cost and harm to the surrounding environment. So, although there are some downsides to wind energy, especially the intermittency, and a certain threat to wildlife, the benefits are impossible to ignore. And that's why we continue to see wind farms being built both on and offshore. Cleveland, do you have any comments?
Yeah, Paul.
Before Cleveland start, please, I'm putting Cleveland in mute, sorry, because he still has
Noise?
background noise, but it's not a problem.
Okay, Paul, I think it's important again to realize that just as with solar, price is amazing. You can overcome almost any objection with enough price incentives. Certainly, noise is becoming less of a problem with new designs in the blades, technologies that have been adapted from submarines for easier hydrodynamic characteristics. The same ones are being applied to the blades, and so we're getting rid of a lot of those problems. The intermittency is a problem in many onshore areas. Most of the offshore regions in the world have overcome that because most of those have much more constant wind flow patterns. And certainly here in Brazil, we have some of the most constant wind flows in the world, and some of the wind farms that we have over 90% uptime. So, I mean, this is amazing for almost any energy source.
Yeah.
But I think it is important. Yes, medium capex. Sure, you need money and for all of the ancillary work. It's relatively low OPEX. Very fast implementation. You can set some of these things up once you have the money set out very quickly. So again, you can achieve installation and first kilowatts very quickly. Of course, yes, location, the right locations are essential, but we're discovering that many more places in the world have adequate locations, especially at the 100-meter height where most of these new large windmills happen to operate. And certainly the footprint is bad because if you have a wind farm, you have many of those columns and so on. But in many places, rural areas, maybe that's not as an impediment as in solar farms. And offshore, of course, that's not much of a problem. The capex of offshore wind farms is more of a problem. That's considerably more expensive. The weather dependence for sure, but less so with offshore wind. And I want to say the environmental impact, not just of the inputs, and because these are basically large generators, electric equipment. Yes, you have a lot of materials for electric equipment, but also in their production and in their decommissioning, as many people point out. What are you going to do with the blades? These gigantic things are going to be very expensive to decommission. Luckily, we're a little bit more advanced than with solar. We're already developing reverse chains for decommissioning some of these blades and finding alternative uses. Again, we're still in the infancy. These pieces of equipment are likely to last 20, 30 years as well. So, that's not imminent. But some of those problems are similar. But the fact that we have offshore, that's really a different category. And we have to say that maybe I foresee, 30 years from now, a lot of these wind farms onshore, they'll probably be abandoned, decommissioned, and we'll have the offshore ones bigger, less intrusive, less downsides and more upsides.
Yeah, because interestingly, some of the new designs coming through where they're using vertical axes, they have these strange names. You've seen things like outside tire garages where they have those spinning
Yeah.
adverts. That's the kind of things that they're looking at as well for generation. But
Yeah, it depends. When you're going local, a lot of those designs, which are intrinsically, theoretically less maximum potential power, but they may make sense in smaller installations. But the one thing that I think is important is we talked about intermittency of winds, but the actual power output of the windmills is actually proportional to the cube of the velocity of the wind. So you'd say, hey, high winds, great. But a lot of these wind farms are designed to cut off
That's a
when
good
the
point.
wind is very high because
Yeah.
of damage concerns and so on.
That's
So
a
you
good
miss
point.
out on the highest potential
Yeah.
generation.
But let me ask you, comparing wind and solar, the whole process,
Yeah.
which one you see more attractive? I mean, in terms of costs, in terms of efficiency, and so on.
Well, if you ask me, I'm convinced that some years from now, most wind farms will be abandoned. So solar will march ahead with new technologies, also solar panels, not CSP, but solar panels. And even though they have their own decommissioning and recycling problems, certainly much more tractable than with wind power.
So you
Other
see
than offshore.
wind more attractive.
No, I think solar is more attractive.
So,
Offshore wind maybe stays in the game, but I think 20, 30 years from now, all of these wind farms will be abandoned. It's ridiculous to have a lot of onshore wind farms that really don't live up to the potential of offshore. Now you could say
Yeah,
the same
okay.
thing about the solar because of
Yeah.
the footprint, but again, if you get more efficient and you get more creative, you can handle some of that.
and you
yeah,
see the same.
I tend to agree. I don't see the abandonment of onshore wind farms happening, but I think solar panels will overtake, and they're simply cheaper to install and cheaper to maintain. But and as we see more increases in the efficiency of the generation of electricity from solar panels, I think wind farms, they will continue to be there, but I don't think we'll see the installation of more of them.
But you see, it's really a pity when we look out over some of these large solar farms, just acres and acres, hectares and hectares of land covered with panels. It's a pity. In some cases where we need forest cover to overcome a lot of the problems, not just because of CO2, because of biodiversity loss. And we're covering the countryside with panels instead of with vegetation. It's a very complex problem.
Very complex.
Immediacy takes some precedence sometimes.
Unless we can float some fans up into the Gulf Stream and capture the energy of that.
Maybe.
Yeah.
Come on, the next one.
Let's go ahead.
Nuclear. Now we can have some fun, because nuclear is a carbon-free form of electricity generation. That's the major pro for nuclear. Yeah, the nuclear plants do have a small land footprint, but they generate a lot of electricity and can be used reliably. It's consistent, it's sustainable, it's renewable, everything. But the cons of electricity, uranium is technically non-renewable, and you have many problems associated with that. I'm not sure I want to cover some of them. For example, we have geopolitical issues. Where is the uranium located? And then we have other geopolitical issues where we don't want certain regimes to be generating nuclear power because of what they can use the depleted uranium for. But the major downside to nuclear is the very high upfront cost, because the buildings themselves are relatively simple to design and build, but the safety elements for those plants are huge. We don't want anything to happen that can cause a major disaster, as we've seen with Chernobyl and the Japanese plant. The Japanese plant. So governments, they spend a ton of money on making sure that these buildings are safe. The operation of the plants is optimal and efficient and safe. But then we have the nuclear waste and the disposal of those nuclear waste. Yeah, we have plants in England like Sellafield that will take nuclear waste, but the political opposition by people living along the train lines, the roadways leading to Sellafield is huge. People don't want nuclear in their backyards. And as I've said, a malfunction can be catastrophic. If the temperature of the nuclear core reaches a temperature higher than the coolant, then we can face what's a potential meltdown. But yeah, as I mentioned, we have a lot of safety built into the processes to make sure that this doesn't happen. But until recently, the biggest con for nuclear energy has been the opposition by a certain generation, my generation. They simply didn't, they typically not in my backyard people. They were quite willing to accept the cheap electricity that was coming from the nuclear plants, but as long as it's in somebody else's backyard. But the younger generations are more optimistic and they're more pro-nuclear because of the environmental or the very low environmental impact that nuclear has. Yeah, the mining of the materials, the refining of those materials, the transport of those materials, they do have major environmental impacts. Cleveland?
Yeah, Paul. I think one important caveat I want to make here is that despite everything, people continue to fear, catastrophic events, but both empirically, statistically, the history has shown that even considering those worst accidents, nuclear is still safer in terms of accidents, deaths, and so on per watts generated than almost any other energy source. So, a lot of it is psychology. The other side is that technology has nowadays improved to the point where you have some designs that are basically impossible to sustain meltdowns because they automatically shut down.
Yeah.
So those things are important to convey to the public so that that is a nuclear has a place with
Cleveland, sorry to interrupt.
Yeah.
The audio is
You have a
breaking
problem with
up.
sound.
Oh, yeah? Did you hear me?
Yes.
Yeah.
Okay.
Yeah.
Yeah, I want to say that nuclear definitely has a place in the energy mix in the world. So that will have to be considered. People will have to understand and accept that it is safe. Certainly nowadays it is safe. Chernobyl is not a good example for the nuclear generating industry. Certainly Japan might be, but also has a lot of lessons of, allowing safety to be compromised on different aspects. So we've made a bunch of advances in that.
Yeah.
But I certainly think the high capex is the major drawback, and the long, tremendous lead times to implementation. We're talking over 10 years, ridiculously long. even if legislation and regulation can cut that down, we're likely to see,
Yeah.
7 years and more. That's very difficult. And of course, the technical constraints for small modular reactors, which are still a ways away, even though a lot of people are working on them. That is the way to go, but it will take a long time.
But the problem these days, Cleveland, is with social media is that if somebody builds a nuclear plant close to a residential area,
Yeah.
somebody's
Not
going
in my
to get
backyard.
on. They're going to get onto the social media and say, "Oh, I've got a sixth finger growing," and
Yeah.
millions of people will believe them.
Yeah. No, I agree. That is an imponderable and up to the authorities and the interested parties that want to set up a plant to convey public audiences and so on, to try to convey to the public
Yeah.
technical information that will make them aware of the risk. Relative risks of a coal plant are very much higher, uh, emissions of mercury and everything else. So
Let
it's
me
not
share.
a
Let me
simple
share
decision.
the question of a pseudoscientist. I do not believe that probably is the best scientist that we have here.
Yeah,
Send shiploads of garbage. Yeah, that's a very, very critical point.
exactly. Nuclear waste, yeah. Given, I admit that is one of the last areas that has been addressed, and it will have to be addressed. The problem is with addressing that is that we still have plenty of room for nuclear waste. So it's not an urgent problem. It's a big problem, but it's not an urgent problem. We can build a lot more nuclear plants and we can handle that nuclear waste, but we will have to deal with that sometime in the future. The other advantages, if you want to consider that, is that nuclear plants can be extremely large. A nuclear center with more than one unit is now in Japan, for example, 9 gigawatts. Now you're talking about as big as
Size.
some of the largest hydroelectric projects in China and Brazil. So certainly in terms of localized power generation, it's very difficult to get anything close to that without, significant pollution concerns. It's not just CO2 emissions. A coal plant is big, but it has a lot of
Cleveland,
emissions.
it seems that the world is rethinking about nuclear. It's being stronger, the idea with nuclear, no?
Yeah, I think the scientists have to do their thing. They have to convey the message to people that nuclear is what it is. It's relatively safe in relation to all the other generating alternatives that we have. That's a difficult swallow for a lot of people who remember, as I do from my age, 3 Mile Island, and then, Chernobyl, and then Japan. Yes, it's fresh in our minds, but we have to understand these are not the same reactors that we had 30, 40, 50 years ago.
At the point of pseudoscientists with 1 year to implement a plant of nuclear, I do not believe that it takes only 1 year.
Well, I think the problem is building one might be relatively fast if you get all the permits. The problem is getting all the permits and going through that licensing process. And indeed, like Paul says, the building of the unit is nowadays an engineering problem that's totally dominated by many countries and companies.
Yeah.
So you can do that. It's the regulation and the licensing, environmental licensing is extremely complex. I'm not saying you have to railroad any project through. It's just that we have to streamline that because it is no more problematical than a power plant run on coal or a large hydroelectric project, which has many problems.
And then you've got the training of the people who are local to the nuclear to work and operate that nuclear plant safely and effectively.
But Paul, 70% of electricity in France is from nuclear. How do they the solution?
To be honest, I don't know how to answer that. The French have been one of the best builders of nuclear plants for a very long time. They used to have like letters to classify the plants, but they don't have the resistance to nuclear plants that other countries do. I think the people are more they're more willing, or have been more willing, to accept nuclear energy in their system. With that, you have the acceptance of having nuclear plants in your area.
Once you're
They,
over a certain threshold, it's easier for the public to accept that. So
yeah,
what the comment
Yeah.
was too much, too many regulations, too much bureaucracy. Yes, a lot of that is due to popular pressure, not due to technical reasons. So once we can overcome the popular misconceptions, I think that we can get over that hump, and then it becomes easier. But it's not to say that France had an easy time. Their units, many of them, took many years over budget, that kind of thing. And lately, we've come to recognize that France is a model for a highly nuclearized energy.
That's right. That's
it,
right.
it's all too easy to say there are too many rules and regulations, because every industry has faced something. And because of that, they've had to introduce rules and regulations. Because people say, why weren't there any rules or regulations to cover such a scenario?
But you see, nowadays it's easy to argue, why was it so easy to install a large coal plant? Forget the greenhouse gases, just the pollution that comes from handling the coal, discharging the ashes and so on. This is hard to understand. So we may have, in many places, somewhat of a double standard. Anything that's nuclear is held to a much higher standard. I'm not saying that standard is too high. I'm saying that we should have that standard for almost all alternatives.
Yeah.
Let's go ahead.
Yeah.
Geothermal.
Geothermal, I used to be a big fan of geothermal, but it never
No
really
longer?
took off. Oh no,
No longer.
I still am. It's just that it hasn't taken off.
Yeah.
It's a very environmentally friendly source of power. All we've got to do is drill down deep, and everybody who's been in the oil industry knows that when you're drilling 2,000, 3,000 meter wells, temperatures are up around 400, 450 degrees centigrade Celsius. Yeah, so we know that we have the potential for creating heat or electricity from geothermal sources. The carbon footprint is almost negligible. There is some pollution, but this is relatively minimal when you compare it to fossil fuels. And it's the renewability of this energy source is, again, like solar, it will outlast the existence of humans.
Yeah.
We have lots of hot reservoirs. These can be aquifers that are close to magma chambers. That energy can be tapped. Although I doubt we'll see any geothermal plants near Yellowstone and anywhere where we see geysers coming to the surface. So it's renewable, it's sustainable, it does have potential. The thing is, I'm sorry, I got myself lost in my own thoughts there. We need temperatures around 150 degrees C to drive turbines, and that's easily achievable with geothermal energy. And we can also use the ground as a source to store the energy, as a heat sink. And basically, you just need something that's around 2 meters below the surface to be able to store that energy. So it can be used as a heat sink, and with the installation of, as I said, a geothermal heat pump just 2 meters below the surface. And energy from this source is very easy to calculate since it does not fluctuate. It does fluctuate, but we're talking over geological time, not tens or 20 decades, a few decades. And like solar and wind energy, unlike wind and solar energy, we can predict the power out from a geothermal plant with a high degree of accuracy.
But it's not more a dream than reality, this type of energy.
It should be reality, but it's still. I don't know why it hasn't been popular. If we take the cons, it is location restricted. We're restricted to places where we have very high geothermal temperatures, very high geothermal gradients, as we say. And you can think of places that are magmatics, volcanic areas, hotspots, just like Iceland, where geothermal should be the prime source of electricity. But some of the side effects are when you drill into these aquifers or into these sources, you're going to frack them so you can get the hot liquids in the aquifer, and that can cause earthquakes. Although the earthquakes are going to be localized, you are going to have earthquakes is probably the wrong word. You're going to have tremors, and you're going to have seismic activity. But I think the biggest problem with geothermal are the high costs, because you've got to drill. Drilling is not cheap. And even though it's cheap onshore, it's still a very expensive operation. You're probably going to have to drill quite a few wells. And yeah, I don't know why geothermal hasn't taken off, but it hasn't. I think we all know that we are living on a planet with a lot of magmatic activity.
Cleveland is an energy for geologists only?
I don't think so. I think that we're now developing exploration professionals devoted to geothermal, just like we have geologists and explorationists devoted to CO2 storage, new areas that go beyond just oil and gas. I think this is the cusp, and we're very close to making major changes. And indeed, like Paul said, the higher the gradient, temperature gradient, and the higher the temperatures eventually at the bottom, the higher the efficiency of the generation itself. Because if you have even up to 700 degrees and so on Celsius, you have very much more efficient generations rather than 200 and 300, which is what people used to accept because they were using, abandoned oil and gas wells to drill. Nowadays, you're having dedicated wells and also a much better understanding of what you need to drill for geothermal. You don't need as an expensive a well as you do for oil and gas. So these realizations are leading to a whole new technology that I think, over the next 5 years, we'll see a major coming down in costs, and that will be the driver.
Not sure.
Yeah.
You don't agree, but cost. You must agree, if
what's the
half, that will change.
and what's the reason that's not be applied?
Oh, the reason is simply that it's still not cheap enough. In some places it is, but on a small scale, so that doesn't make a big dent in the energy mix. When we are able to get this down on a large scale to half the cost currently, I think then we'll see many more applications. In fact, one of the companies that I'm a director of, the Geoscience Department, is devoted for exploring, identifying geothermal potentially high potential areas for geothermal exploration. Not just oil and gas. This is focused on geothermal.
No.
This is something that 5 years ago didn't exist. No one was doing this, doing exploration for geothermal. Now it's part of a business of a company. And this is just an expansion of ongoing expertise in oil and gas, and it's going to be more separated out.
Maybe good for the next century.
Okay, I call the next century the next 5 or 10 years. But
Yeah, yeah.
Let's go to the last
yeah,
slides.
Well, I only
Paul.
threw this in because coal bed methane hasn't been mentioned. Basically, my question is this still a viable energy source? It was always talked about, it's been talked about since the late 80s through to the early 2000s, but I don't hear anybody talking about coal bed methane anymore. Maybe we can have this as a future topic.
yeah. I think again, price is the big thing. Coal bed methane is a viable uh, energy source if you want to produce methane, but not everywhere, and even not in all coal seams. So very specific still. But I wanted to bring up two things. Combined hydrogen, because this is hydrogen as an energy source, not as a carrier. Only white, which is naturally occurring hydrogen,
Yeah.
and gold, which is naturally stimulated hydrogen production. Yes, we have wide potential availability because throughout the world, any abandoned oil and gas well is a potential source. It's scalable and fast because once you get the details just right in terms of the kinds of technology you have to apply to bring down the cost. The cost that we're talking about is $1 as opposed to about 6 or 7 or 8 for green hydrogen. So naturally, the advantages would be
Yeah.
extreme. Certainly low emissions, but as we already mentioned before, hydrogen is not without problems, including large likelihood of fugitive emissions, a relatively high greenhouse potential, at least 10 times CO2, so that's problematic. Also problematic transportation, storage, and applications,
Yeah.
but the availability can be made available there. And I think we're probably seeing this year or next large pilot programs being put into place. The next step years.
Your sound is bad. It's a fail.
Okay, this is something that can be scaled up. I think we wanted, Cavagna, if you can go, I had a slide on hydro. I just wanted to point out two things on hydro. No, up.
This one?
But before, one more. Oh, yeah, hydro. A lot of people are enamored with hydro, which of course has nowadays limited potential because we don't have too many places in the world where we can find another Three Gorges or another Itaipu large, 10 gigawatt installation.
Like Norway.
Yeah, like Norway. So, the potential is less. But I wanted to mention that we also have a lot of negatives that people don't want to bring up with hydro because they say, oh, hydro is so clean and just a water reservoir has so many advantages, regulation of the water flow.
But the impacts on environmental. Yeah.
Yeah, but that is not necessarily good. A lot of times you inundate whole forests and you have methane emissions which are higher than 20 years of operating coal plants. Really. In Brazil, we have one of the worst examples. Balbina is a large hydro project. Now we can calculate its emissions are worse than if we implemented a coal plant of the same size. These are real problems which were swept under the rug and people didn't recognize. Certainly long lead times.
Okay.
But hydro can still be important in some places, especially for the storage aspect, because you can have pumped hydro. And there we're now talking about hydro not as a source, but as a regulating mechanism where you can produce electricity, pump it all the way back up during times of surplus. So that's important to just mention because people can't forget about some of these other aspects of hydro.
Yeah, but the problem is, again, it's location
Yes.
specific.
Location specific. There.
That's right. My conclusion for the day is that Paul loves geothermal and Cleveland loves hydrogen.
That's about it.
Reasonable.
In between, there's a lot of overlap.
Well, as we're drilling for the geothermal energy, we'll be releasing hydrogen
Maybe we'll. If we
Maybe.
capture it, that'll be okay. Okay,
Gentlemen,
that was good.
what a pleasure today with these other energies instead of coal, oil, and natural gas was the last one. Thank you so much.
Thank you.
Great, guys.